This video, we're going to talk about 3.2 Objective 1, where we analyze questions involving the derivative as a function conceptually. First question for a given function f, what does f prime represent? F prime is the slope of the function, as the slope function of f. Now we have a linear function here. If f prime of x is equal to negative 10x minus 6. Find the slope at x equals 0, 7, and 8. So we have that slope function. Negative 10 times 0 is 0. 0 minus 6 is negative 6. Negative 10 times 7 is negative 70 minus 6 is negative 76. And negative 10 times 8 is negative 80. Negative 80 minus 6 is negative 86. Really not a lot of work to do there. Why is the notation dy dx used to represent the derivative? That would be d, the derivative dy dx is the limit of delta y over delta x as delta x approaches 0. So this is the average rate of change. And it approaches the instantaneous rate of change here. Instantaneous rate of change as the change in x gets close to 0, as the 2 points get close together. All right. Number 4, if f is continuous at a, must f be differentiable at a? No. We have things that we'll call cusps later. I think this book calls them corners. So if f is continuous at a, it's not necessarily true that the limit that defines f prime exists at a. So we have cusps and corners. So think about that sharp points like this or like this in the function, it will not be differentiable at that sharp point. Even though we can draw that part of the curve without picking our pencil up off the paper, it's continuous there, but it's not going to be differentiable there. All right, if a function is differentiable for all values of x, then it is continuous. That's true. Differentiability implies continuity, not the other way around. So true, because if f is differentiable everywhere, then that means that there are no holes anywhere, no jumps, no vertical asymptotes if it's continuous everywhere, and it's therefore continuous everywhere. So I would say not just no holes, but jumps or vertical asymptotes are the other types of discontinuities. The function f of x is equal to x, absolute value of x minus 1. That's the absolute value function shifted 1 to the right. It's got a corner there at x equals 1. It is continuous for all x, but not differentiable for all x. That's true because it's not differentiable at that corner 1, 0. Is it possible for the domain of f to be open interval a to b and the domain of f prime to be closed interval a to b? No, because it's impossible to draw a tangent line at a point that's not in the domain. All right, that's it for this video. We'll come back next time and talk about 3.2 Objective 2, where we find derivatives of functions using limits. See you for the next video.